In this video, you will learn different numeral bases. In our daily life, we use different forms of measurement, like these ones here. So in this video, you will learn 3 numeral systems: binary, denary, and hexadecimal.
Before we start with conversion of numeral system, we need to know each of numeral system. Denary system is the most common numeral system in the world. It consists of 10 numerals, 0 to 9. The number 10 at the bottom right indicates its space. We can omit it. In a denary number, the value of each digit depends on its position. It's called the place value. The place value of each digit is 10 times that of the next digit to its right. Binary system can be used in computers in order to execute high-speed operations. It consists of only 0 and 1. The number 2 at the bottom right should not be omitted to cause no confusion. In a binary number, the place value of each digit is 2 times that of the next digit to its right. Similar to the binary system, the hexadecimal system is also used in computers. It consists of 16 numerals, 0 to 9, and A to F. The values of numerals A to F are as follows. A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. The number 16 at the bottom right should not be omitted for the same reason as binary number. In a hexadecimal number, the place value of each digit is 16 times that of the next digit to its right.
Now that you know the principles of binary numbers, let's begin with the extension. Let's use 2 simple numbers. For the extension, what you have to do is get a number and multiply each of them by its according place value. Let's take another example. The expanded form of 1, 1, 1 is 1 times 2 to the power of 2 plus 1 times 2 to the power of 1 plus 1 times 2 to the power of 0. So what about the conversion? For the conversion, you will just solve them. For example, 1 times 2 to the power of 2 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 0 will be 4 plus 0 plus 1, which is 5. So 5 is the denary form of 101. Let's take another example. The expanded form of 111 is 1 times 2 to the power of 2 plus 1 times 2 to the power of 1 plus 1 times 2 to the power of 0, which will be 4 plus 2 plus 1, then 7. Now that you know how to convert the binary numbers, let's proceed with the hexadecimal numbers. The process of converting hexadecimal numbers is similar to the one of binary. For the extension, let's use 2 simple numbers. The next step is get the number and multiply each of them by 16. For example, 7d5 will be represented as 7 times 16 to the power of 2 plus 13 times 16 to the power of 1 plus 5 times 16 to the power of 0. To convert it to denary, you have to solve them, getting 1792 plus 208 plus 5, then getting 205. The same thing for A93.
Now we know that any binary or hexadecimal numbers can be converted into denary numbers. In fact, we can convert any denary numbers into binary or hexadecimal numbers too. Take 12 as an example. By dividing it successively by 2, we can convert it into denary number. Divide 12 by 2. The quotient is 6 and the remainder is 0. Divide 6 by 2. The quotient is 3 and the remainder is 0. Divide 3 by 2 again, the quotient is 1 and the remainder is 1. Now follow the arrow to get the binary number. Therefore, 12 is equal to 1100 in binary number. Like this, we can also convert the denary number into a hexadecimal number by dividing it successively by 16. Take 2019 as an example. Divide 2019 by 16, the quotient is 126 and the remainder is 3. Divide 126 by 16 again, then the quotient is 7 and the remainder is 14. Now you follow the arrow to get the hexadecimal number. Therefore, 2019 is equal to 783 in hexadecimal number.
So, when do we use binary codes in our daily life? Times ago, people needed a system to classify their products. For this system, a binary coding would be needed, so their computers would be able to read it. So they came up with the barcode. A barcode is separated in 95 evenly separated in black or white columns. When the scanner is scanned bar, the laser will not be reflected by the black column, which means 1. The white column will reflect the laser, which means 0. All this information will be sent to the computer and will show the information about the product. In our daily life, we always come across different measuring units. Among them, we learned 3 different kinds of numeral systems: denary, binary, and hexadecimal systems, and also the conversion between these numeral systems. We hope now you know this topic, and thank you for watching this video.